In today's lesson, we're going to be talking about the unit circle. Now we will talk about the unit circle. What is a unit circle? A unit circle is simply a circle centered at the origin, 0, 0, with a radius of 1. That's all it is. Well, if we have a radius of 1, we go out 1, that makes this point 1, 0. Over 1, up and down 0. That makes this point up here, back and forth 0, up 1, so 0, 1. To the left here we've got negative 1 and up and down 0, and down south we've got down back and forth 0, down negative 1. If that's the case, then if this is a radius of 1, then this blue line is also a radius of 1, and we can create an angle with the horizontal x-axis, we'll call it theta. Well, any point on my unit circle I can designate as x, y. Over x, up y. I can say we're going over x, so this distance here is x, and I go up y, so that distance there is y. Well, theta is also, if I consider x compared to theta, this is adjacent over 1. Adjacent over 1 is cosine, so I can say that cosine theta is x. If I'm considering theta, I can say opposite over my 1 radius is sine theta. Well, sine theta will then equal y if it's y over 1. And tangent theta is always y over x, or you can consider tangent theta equal to sine theta, which is y, over cosine theta, which is x. Here I've taken the unit circle and I've blown it up, so we're just considering quadrant 1. In quadrant 1, both my x and my y are positive. If I define theta as pi over 6, we consider pi being 180 degrees. Divided by 6 would give us 30 degrees. So essentially we have a 30, 60, 90 triangle where our radius is 1. In other words, our hypotenuse is stuck at 1. Well, we remember back to our special triangles, if we consider this is 30 degrees, across from 30 degrees was 1/2, and across from the 60 degrees was the square root of 3 over 2. So we can find cosine of pi over 6 very quickly. Cosine is adjacent over hypotenuse, which would be the square root of 3 over 2. Sine is, if I erase this for the adjacent cosine, sine is opposite over hypotenuse. The opposite is 1/2 over my hypotenuse is 1 is 1/2. Tangent of pi over 6 is defined as opposite, which is 1/2 over adjacent, which is the square root of 3 over 2. Which is the same as saying 1/2 times the reciprocal here would be 2 over square root of 3, which would ultimately give us, if we cancel the 2's, 1 over the square root of 3. Sometimes you see that rationalized as the square root of 3 over square root of 3. We would get the square root of 3 over 3 if we multiplied by a fraction equal to 1 there. Now let's consider the unit circle where our theta is no longer pi over 6 but pi over 3. Pi is 180 divided by 3 is 60. So if that's the case, this is a 30, 60, 90 triangle where my hypotenuse is 1. Well, if that's the case, we know our ratios are across from the 30 degrees is 1/2, and across from the 60 degrees is the square root of 3 over 2. So that allows us to quickly figure out that cosine of this theta, pi over 3, is adjacent over hypotenuse, which is 1/2. Sine is opposite over hypotenuse, which is the square root of 3 over 2. And tangent is opposite over adjacent, which is the square root of 3 over 2 divided by 1/2. When I multiply by the reciprocal, I'll ultimately get just the square root of 3 over 1. Let's now consider the unit circle when our theta is pi over 4. Well, that's 180 degrees divided by 4, which gives us 45 degrees. Well, if that's the case, we know this is the same angle here, 45 degrees. If our radius has to be 1, or our hypotenuse has to be 1, then we know from our previous work that this is square root of 2 over 2, and this is square root of 2 over 2. So cosine of this angle is adjacent over hypotenuse, which is the square root of 2 over 2 divided by 1, which is the square root of 2 over 2. Sine is opposite over hypotenuse, which is the square root of 2 over 2. And tangent is opposite over adjacent. Well, this divided by this will give me just 1. Finally, let's consider when our theta goes to pi over 2. Well, pi over 2 is 180 divided by 2 is 90 degrees. So we could also consider this 90 degrees. Well, what is our x, or our cosine at 90? Well, it's up here, and we see that our x is 0. How about our sine at 90? Well, our sine is our y coordinate, and that's 1. What is tangent? It's our tangent is sine over cosine, so our tangent at this point is undefined. We have no definition there. Undefined. To help remember what the sign, that's S-I-G-N, of our trig ratios are, it's helpful to consider the different quadrants of the unit circle. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's on the Cartesian plane. And I remember all students take calculus. In this first quadrant, sine, cosine, and tangent, all my trig ratios are positive. In this quadrant, only sine is positive. In this quadrant, only tangent is positive. And in this quadrant, only the cosine is positive. Now, think about it like this. If cosine is x, where is x positive? In the all and in the fourth quadrant. This side, that's where x is positive. Think about sine, it's the y. Well, where is sine positive? Sine is positive here and here. Above, well, that's where y is positive as well. All and tangent are positive in those categories. We can think more about that. Let's now talk about the symmetry of the unit circle. Again, I have quadrant 1, 2, 3, and 4, and I know it's all sine, tangent, cosine. All students take calculus. That's where those particular trig ratios are positive. If I'm asked to find the sine of 150 degrees, I know that this angle here is 150 degrees. Well, with a straight line, I have 180 degrees, so this means that this is 30 degrees. I can make a triangle here with 30 degrees there. Well, I know that all, meaning sine, cosine, and tangent, and sine are positive here. It's like sine is the y-coordinate. So where is sine positive? Above. So any angle in the second quadrant for sine is going to be like an angle in the first quadrant for sine. So it's 30 degrees here. In the first quadrant, it's also going to be 30 degrees. And I can think about what this triangle is going to be. If my hypotenuse and my radius, one and the same, are 1. Across from a 30-degree angle, we have 1/2. Across from that 60-degree angle, we have the square root of 3 over 2. You see how important it is to know those triangles. Well, if the sine of 150, this was our original angle here, is the same as sine 30, it's equivalent to sine of 30 degrees. It's very convenient to relate any angle to an angle in the first quadrant. Well, my sine is going to be opposite over hypotenuse, which is equal to 1/2 over 1, or simply 1/2. The key concept here is because sine and all trig ratios are positive in this quadrant and this quadrant, anything in the second quadrant I can relate to something in the first quadrant, provided I'm talking about the y-coordinate or the sine. Cosine and the unit circle. If I'm asked to find cosine of 225 degrees, again I can relate it to the unit circle. All students take calculus. So cosine is like the x. The x is positive to the right and negative to the left. If I have 225, I can relate that to, I have 180 over here and 270 down here. So 225 will be in the third quadrant. 225 minus 180 gives me 45 degrees. So I can make a triangle here of 45 degrees. Well, if that's 45 degrees, this is 45 degrees, and that's 90. My hypotenuse is the same as my radius. It's 1. And remember, this is the square root of 2 over 2, and this is the square root of 2 over 2. Well, we're going in a negative direction. So this is negative square root of 2 over 2, and we're going down. So this is also negative square root of 2 over 2. Well, what is cosine? It's adjacent. If this is my angle, this is adjacent over the hypotenuse, which will be adjacent is negative square root of 2 over 2, all divided by 1. Going further with this example, I could also ask, what is an equivalent angle to cosine 225? Well, we see that cosine means x, and x is negative on this side of my y-axis. If we consider this angle here, which is 135 degrees, 135, to that point there, I'm also going to have, I'm going to be 45 degrees short of my horizontal, which is 180 degrees. Well, again, with a 45, 45, 90 triangle, we have the square root of 2 over 2 for this side, and the square root of 2 over 2 for this side. Here, again, I'm going in the negative direction for x, so my sign here is negative square root of 2 over 2. My hypotenuse or my radius is 1. So my cosine still is negative square root of 2 over 2. Let's now consider tangent of 300 degrees. We know all students take calculus. Tangent is positive in the all and the tangent region. So in quadrants 2 and 4, we have a negative tangent. If we're talking about 300 degrees, this angle here is going to be 300. Well, then this angle here is 60, because we know we have 360 degrees in a circle. I can make a triangle there, and if this is a 30, 60, 90 triangle, I know the ratios go 1. Across from 60 is the square root of 3 over 2, and across from my 30-degree angle, I have 1/2. Well, if I'm going over this way, the 1/2 is positive, and I go down, the square root of 3 over 2 is negative. Well, what is tangent? Tangent is the ratio of opposite to opposite to adjacent. Opposite of this angle of 60 degrees would be negative square root of 3 over 2 divided by 1/2. If you multiply by the reciprocal, which is 2, you'll get negative square root of 3. Where else do we see that angle? Well, right across here. If this angle here is 60, this angle here will also be 60 degrees. And we will have 30 degrees up here, meaning this is 1/2 square root of 3 over 2 and 1. Well, my tangents here are negative and my tangents here are negative. And if I do opposite over adjacent, I get square root of 3 over 2 divided by, well, if I'm going this way, I really have negative 1/2 divided by negative 1/2, again, will give me negative the square root of 3 when I multiply by the reciprocal here, which is negative 2. We can see that this angle is the same. This angle, 300 degrees, is the same as this angle. Well, if this is 60 here, then our angle is actually 180 minus 60 is 120. So tangent 300 is the same as tangent 120.